Okay, so my drawing is some sad puppy stuff. No simple closed curves here for the polygons. The question is, how many triangles are there in the 100th figure, the nth figure? Well, you know how you are. You would draw 100 figures and then count up the triangles, or that's how I am, and I find that meaningful. But we could look for a pattern instead. Notice that we've got our first figure, our second figure, our third figure, and this would continue. In that first figure, we could see how many triangles there are. There's just one. In the second figure, count them up. Okay, well, we've got 4. In the third figure, oh, that's 9. Okay, so how many triangles would there be in the fourth figure? Let's look for a pattern. So we've got 1 little triangle, 4 triangles, 9 triangles. These are all perfect squares. That 1 is the same as 1 squared. 4 is the same as 2 squared. 9 is the same as 3 squared. So what we're doing is we're just taking the name of that triangular number and we're squaring it. So if the question is, how many triangles will there be when we're on the 100th figure? Okay. Well, let's just take that number, 100, we'll square it. Or in other words, that's 2 factors of 100. That product is 10,000. You keep all of the zeros. Okay, so that's the answer to the first question, that there are 10,000 smaller triangles in the 100th triangular number. As for the nth triangle, well, that would be for any counting number. That would just be n times n, or n squared. So n squared little triangles in the nth triangular number. Problem solved. Now when we're looking to predict that pattern, we're considering simple things like addition, subtraction, multiplication, division, and in this case, exponents.